thing to be aware of, and this is something, we're not going to spend a whole lot of time on this, but it's something I want you to be aware of. So this whole time we've been telling you what? That covalently bound compounds are all made of molecules, right? Individual, discrete units. We can isolate a molecule of sugar. We can isolate a molecule of carbon dioxide. Well, turns out, not always. So, we have these things called covalent network compounds. If any of you go on to take a college geology course, anybody doing environmental science or anything? Because if you do anything that involves, anyway, if you take a college geology course, you will see discussions of one in particular. Did you know that oxygen makes up a large part of the Earth's crust? Isn't that weird? That's not how you think of oxygen. No, 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 no. Oxygen's in our atmosphere, not in our rocks. Well, actually, so silicon dioxide, which is how many silicon, how many oxygens? One silicon, two oxygens. Yeah, silicon dioxide is a major component of a lot of rocks in the Earth's crust. And so it's not the way we think of oxygen. It also happens to be one of these covalent network compounds. So it forms a big lattice-like thing. It's not discrete molecules. So it acts more like an ionic compound than a covalent one. Despite that, it's still a covalently bound compound. There's no difference in the naming conventions. We still name it like a molecule, but what you should be aware of is that if you're dealing with a covalent network, the formula just represents the ratio. Okay, it just represents the ratio of charges, just like when we talk about ionic formulas, but it behaves a little bit differently. So, and that's about all the deeper into that idea we will go. Okay, now this is the stuff that everybody gets excited about when we talk about chemistry. And if you look on the very bottom of your Ion Bible, there is a little box that says common acids. So these are all molecular. Acids are all molecular compounds. There are two basic types. There are binary acids, there are oxy acids. Chemistry and chemical naming being as creative as it is, hold up fingers. How many things do you think are present in a binary acid? Wunderbar. You're all quite clever. Yeah, two things. Just two things. So, stomach acid. Who knows what acid that is? What's the acid churning in your gut? Oh my goodness, really?
Acidic.
Hydrochloric. Hydrofluoric's a little bit crazy. But that's okay. Yeah, you were on the right term. It's hydrochloric. It's hydrogen and chloride. That's a binary acid. The other type of acid is an oxy acid. Again, chemical naming being so creative. Guess what element is present in all oxy acids? Oxygen! That too, actually. But, yeah, oxy acids. All acids contain hydrogen. And we'll get into chapter 15. We'll talk about them being proton donors. Remember that hydrogen ions are just little naked protons. A lot of the polyatomic oxy acids are actually related to a polyatomic ion. So, find your nitrate ion. Huh? Nitrate ion? What's the formula for the nitrate ion, Mr. Railing? NO3, and it's got a 1 minus charge. We bind that covalently to a hydrogen. What we have is nitric acid. We can then split that apart in solution. We get hydrogen ions out of the deal. Most of the polyatomic ions can be bound up with hydrogen and form an acid. The binary acids are pretty much all a halogen plus hydrogen. So we've got hydrochloric. Guess which halogen that is? Chlorine. We've got hydrofluoric. Fluorine. We've got hydrobromic. Bromine. Can you guess what the fourth one is? It's the one that's the most challenging to say. What would it be? It's hydroiodic. Yeah. Because it's hydrogen and iodine. So, we will deal a lot more with acids in the next couple chapters. You will do some labs. You don't have to play with anything, but you will do some labs that involve the use of acids, yes. Okay, salts. So, yes, the difference between science and messing around is usually keeping all your fingers. Salts. It's not just table salt anymore. Does anybody here have someone in their family who is on a sodium-reduced diet? Nobody? Very often elderly relatives, grandma, grandpa, aunt, uncle, whoever. I don't know if they still, I think they still sell it. Potassium chloride. And it comes, you know the dark blue salt shaker, the little paper salt shaker from Morton? Well, the potassium chloride comes in a light blue shaker. And you would never mistake it for sodium chloride. Because it tastes weird. It just tastes weird. If you know somebody on a sodium-reduced diet, ask them if you can try their special salt. Yes, and it's horrible stuff. Salt is not just sodium chloride. Potassium chloride is a salt. Magnesium chloride is a salt. Oh, goodness. Calcium carbonate's a salt. So all a salt is chemically is when we have taken the anion from an acid and we've mixed it with typically a metal. So sodium's a metal, magnesium's a metal, zinc chloride is another salt example. We have a few things that where we've got an acid that contains an additional hydrogen, so that's where we get things like the bicarbonate ion. Okay? Not a whole lot more to say about that. Now, this is where we're going to stop today. We'll talk about oxidation numbers tomorrow. What I'm going to do right now is give you some time to work on the homework. I would highly recommend that you use either the problems in your homework, of which there are plenty. I would also suggest that you use the practice problems in the chapter for naming. Remember, your quiz tomorrow will be not only multiple choice, but some fill-in. You know, write the formula for blah, blah, blah. Name this compound. Things like that. Question, sir?
No, when we name them, like spelling.
You've got your Ion Bible. I expect you to spell things correctly.
Wait, yeah, that's where I get confused. Should really know.
If you look at the bottom, hydrofluoric acid should give you a good clue.
Oh.
Yeah,
Sorry.
All the atomic masses, all the common isotopes. Other questions?
yeah. How do we tell the difference?
How do you tell the difference between what?
I don't like, yeah.
You want to do some mixed practice?
Oh,
Okay. We'll stop this.